This example looks slightly different, but the ideology is the same. Now we have a complex exponential x of n, which contains a real part and an imaginary part. It is repeated after every 4 samples. From the definition of period, we understand that x of small n plus big N equals to xn. If this relation is satisfied, a period is referred to as capital N. For this particular function, we have x of n plus 4 equals to xn for all values of n. Thus, we can infer the period n equals to 4. Since period n equals to 4, we can refer that the fundamental frequency of omega 0 equals to 2 pi over n equals to 2 pi over 4 equals to pi over 2. From the definition of this signal, we could get coefficient ck and the range of k is from 0 to 3. So how to get this ck? We perform inner product on x of n and e to the power of j k omega n, where omega is the fundamental frequency that we calculated here, which is pi over 2, and x of n equals to e to the power of j pi over 2n. The expression of inner product x of n and e to the power of jk omega n is ck equals to summation of e to the power of j pi over 2n times n to the power of negative jk pi over 2n equals to summation of e to the power of j pi over 2n times 1 minus k, where n is from 0 to 3. So we need to note that we replace the value of n from 0 to 3, that would be 1 period. Now we can calculate ck accordingly. When k equals to 0, we have c0 equals to e to the power of j pi over 20 times 1 over 0 plus e to the power of j pi over 21 times 1 plus e to the power of j pi over 2 times 1 plus e to the power of j pi over 3 times 1. So c0 equals to 1 plus j minus 1 equals to 0. c1 equals to e to the power of j pi over 2 0 times 0 plus e to the power of j pi over 2 times 1 times 0 equals to e to the power of j pi over 2 times 0 plus e to the power of j pi over 3 times 0. So c1 equals to 4. c2 equals to e to the power of j 2 pi over 20 times negative 1 plus e to the power of j pi over 2 times 1 times negative 1 plus e to the power of j pi over 2 times negative 1 plus e to the power of j pi over 3 times negative 1. So c2 equals to 1 minus j minus 1 plus j equals to 0. c3 equals to e to the power of j pi over 20 times negative 2 plus e to the power of j pi over 2 plus times 1 times negative 2 equals to j to the power of j pi over 2 times negative 2 plus e to the power of j pi over 3 times negative 2. So e3 equals to 1 minus 1 plus 1 minus 1 equals to 0. Hence, we can see that ck equals to 0 for all values of k except c1 equals to 4. So now we can plot the value of coefficient ck against k in the following manner. This graph can also be interpreted as discrete time coefficients of the signal for varied values of omega. These values of omega are the component frequency, and component frequency are 0, omega 0, 2 omega 0, 3 omega 0, where omega 0 is calculated as fundamental frequency pi over 2 in the first slide.